Hello, I'm Rebecca Waters, Editor-in-Chief for Forensic Magazine. I want to welcome everyone to today's webinar brought to you by Life Technologies. Today's presentation is Enhancing the Sexual Assault Workflow. Following the presentation, we will have a Q&A segment. I encourage everyone to submit questions at any time by typing into the designated section on your screen. The presentation will be available on demand so you can view it again at your convenience or share it with others. You will receive a link via email within the next couple of days. Today's speakers are Allison Holt and Jack Ballantyne. Jack Ballantyne is a professor of chemistry at the University of Central Florida and an associate director at the National Center for Forensic Science in Orlando, Florida. Allison Holt joined the Human Identification Group at Life Technologies in 2008 and has worked on the development of novel DNA extraction, quantification, and genotyping technologies for the forensics market. I will now turn it over to Allison. Enjoy the webinar.
Hello, my name is Allison Holt, and I'm a scientist here at Life Technologies. And today I'm going to be talking about workflow improvements for analyzing challenging mixture samples. So today in this webinar, we'll be presenting two new kits, which will improve the quality and quantity of results from sexual assault samples. And the first kit is our next generation Quant kit, which is designed to work with our next generation STR kits. The second kit I'll be talking about is one of these next generation STR kits, Yfiler Plus. Then Dr. Jack Ballantyne will be showing how his lab has used these new technologies to process challenging sexual assault samples. So some background on sexual assault in the United States. Rapists are more likely to be serial criminals than a serial rapist. So in the U.S., there's actually one victim of sexual assault every 2 minutes. And almost half of rapists who are released from prison are rearrested within 3 years of their release for another crime. So processing sexual assault cases not only helps bring closure to the victim, their family, and the communities, but can also help prevent or solve other serious crimes. So our newest DNA quantification kits are Quantifiler Trio and Quantifiler Human Plus, or HP for short. These two kits are identical with one exception. The Trio kit contains a Y marker, while the HP kit does not. These kits were designed to give you accurate results more quickly with challenging samples. They enable you to evaluate sample quality and quantity in a single reaction. And by quality, I mean that the IPC has been improved to deliver results that correlate to dropout in our next generation STR kits. We also have a new quality index, which I'll be talking about later in this talk, which provides an assessment of degradation in the sample. And finally, we have accurate negative results to deliver confidence in downstream processing decisions. So these kits are more sensitive to low copy number DNA samples. So these kits offer greater correlation with downstream results when used in conjunction with our latest generation STR kits. So some of the processing improvements that we've made with these new quantification kits are we have greater sensitivity and more accurate results with challenging low concentration samples. So this enhanced sensitivity and an improved male target in our Trio kit enable more accurate results for mixture samples, which contain low concentrations of DNA or low ratio mixture samples. And I'll be showing you some data on this later in this presentation. So there's better correlation of male to female quantification reactions, even with great excesses of female DNA. And we also have more consistent results for low template samples actually containing sub-picogram concentrations of DNA. And finally, we've improved the workflow efficiency. So now the PCR cycling time has been reduced to about an hour, and we've reduced the number of standard curve points. Previously, we had 8 standard curves, and now standard curve points, and now we have 5 to 6 data points. So our other new kit that I'll be discussing in this presentation is the Yfiler Plus PCR Amplification Kit. So this is our next generation y-STR kit. It has increased potential for discrimination of male relatives by using an expanded marker set, and we have increased haplotype resolution. So it's actually highly successful in differentiating between closely and distantly related males. This kit has greater sensitivity to recover more alleles with mixture and low concentration samples. So there's improved recovery of alleles and intracolor balance in male-female mixtures containing excess amounts of female DNA, as well as improved resolution capacity for male-male mixtures. And also the inhibitor tolerance for this kit is much higher, so there's higher recovery of alleles in inhibited and also degraded DNA samples. So this is showing some data with our next generation quantification kit. This is the Quantifiler Trio assay, and the results are comparable with the Quantifiler HP assay. So this is a DNA dilution series, and the quantification range for this kit is actually going from 100 nanograms per microliter all the way down to 5 picograms per microliter. So the dynamic range is much greater than current on-market quantification kits. And as you can see, on the x-axis I'm showing the expected DNA concentration, and on the y-axis I'm showing the measured DNA concentration. And we actually have a linear range actually below 1 picogram per microliter. So the sensitivity for this kit is much higher than previous generation kits. So for these DNA dilutions, I took the sample which had 3 picograms per microliter and added 15 microliters of this sample to the GlobalFiler reaction, which would be 45 picograms of DNA. And as you can see, most of the alleles are recovered in GlobalFiler. In this case, it was 35 out of 40 alleles are recovered with less than 50 picograms of DNA. And this is some male-female mixture data from this trio assay. Remember, the trio assay is the one that contains the Y target. So these are mixture samples going up to a 1,400-fold excess of female DNA with a constant 20 picogram per microliter of male DNA. And as you can see, the Y target shown here in blue remains constant with a 1,400-fold excess amount of female DNA in this assay. So a new feature that we have in our next generation quantification assays is this quality index. So we have a large autosomal target and a small autosomal target. And the amplicon size for the small autosomal target is roughly 80 base pairs versus 200 base pairs for the large autosomal target. So you can imagine in a degraded DNA sample, the quant value for the large autosomal target will be lower than for the small autosomal target. And that's what I'm showing here, is artificially degraded DNA, and as the DNA degradation level increases, the large autosomal quant is decreasing at a higher rate than the small autosomal quant. So this is useful for the customer as an indication of how much degradation is present in the sample, and the difference between these two targets will assist in identifying possible degradation in the sample. So showing this new quality index in practice, this is NGM Select kit results. And in the first panel, I'm showing a blood sample, which has a quality index of roughly 1, which is what you would expect to obtain if a sample was not degraded. And you can see in this first panel that there is not a ski slope effect, that the peak heights are relatively consistent. For the second panel, this is a sexual assault trace, and this is medium level of degradation. So the quality index is roughly 5, and there is some allele dropout for the larger loci. Then for the last two panels, we have highly degraded DNA. So here the quality index in both cases is greater than 30, and so most of the alleles are dropping out in this sample. And now I'm showing the Yfiler Plus kit configuration. And as you can see, we've added a lot more markers. There's a lot more information. We actually have 342 alleles in virtual bins in the Yfiler Plus kit. And all of the loci that are in the Yfiler kit are also present in Yfiler Plus. So we also have 11 mini STR loci in this Yfiler Plus kit. And we have new y-STR markers. So there are 6 rapidly mutating y-STR markers and 3 new y-STR markers that are standard markers. This is a representative electropherogram with Yfiler Plus for 1 nanogram of 007. This was run for 30 PCR cycles and then run on a 3500. And as you can see, this is a 6-die kit, and there are 27 amplification markers. So this is showing some data. This data is courtesy of Dr. K. Ballantyne, and it's demonstrating the improved differentiation between male relatives with this Yfiler Plus kit. So this yellow line here is showing the theoretical rate of differentiation with the Yfiler kit, and the blue line is showing the theoretical rate of differentiation with Yfiler Plus. So the yellow is Yfiler and the blue is Yfiler Plus. And the male relative differentiation actually increases by 3-fold, which results in a per meiosis mutation probability of 0.15 with Yfiler Plus versus 0.05 with Yfiler. And as you might imagine, the majority of this increase is coming solely from the inclusion of these new rapidly mutating y-STR loci. So for Yfiler Plus, hypothetically, males separated by at least 7 generations will always be separated, whereas you would need 21 generations with the Yfiler kit. So on a practical level, this increased rate of male relative differentiation results in greatly enhanced resolution of male pedigrees with the Yfiler Plus kit. And empirical testing of 53 relative pairs from 45 pedigrees demonstrated that the theoretical estimates are slightly lower than the rate of differentiation in this sample set. So that's why in this plot that I'm showing here, the observed rate of differentiation, which is the star points, are always a little bit higher than the theoretical rate of differentiation, which is the lines. And now I'm going to turn it over to Dr. Jack Ballantyne, and he'll be talking about how he's using these kits to process very challenging sexual assault samples.
Well, thank you, Allison. Hello, good evening, good morning, or good afternoon, depending upon where you are, and welcome to this webinar. One of the good things about such webinars is that I don't have to dress up and wear a tie, but then again, I no longer wear a tie anyway, so it's maybe not so much of a benefit. I want to talk to you today about some of the work we've been doing that concerns the field of sexual assault investigations. Specifically, my lab has over the last few years been interested in trying to extract the genetic profile of the semen donor in extended interval post-coital cervical vaginal samples. Today I'm going to talk to you about some of the new technological tools that we have evaluated using our particular types of samples. The idea is that the processing of sexual assault evidence that by its nature more often than not contains mixtures of cells from a male assailant or consensual donor and a female victim, it's a mixture, would benefit from having accurate and reliable tools that would help the forensic scientists make decisions about the type of DNA testing to perform downstream. Right? So basically, in fact, there are many other non-sexual assault case scenarios, other case scenarios involving male-female mixtures that are not sexual assaults. And these tools would also benefit these investigations too. So I'm going to talk about sexual assaults, but these tools can be used in any mixture investigations, whether it's male and female admixtures. So one could benefit from these tools, and basically the question one could ask is basically, should one type the sample with autosomal STRs? Should one type the sample with y-STRs? Should one type with both? These are decisions that have to be made often. If there is no male DNA, then should we even attempt to type the samples at all? It may be that one is looking for the male DNA. If there's no male DNA present in a vaginal swab, there's no need to process the swab any further. It looks as if we may have the tools to make these decisions, and my talk today is basically going to just show you some of the data we've amassed in this area. So firstly, however, I'd like to mention that SWGDAM, in its infinite wisdom, is coming out with a new set of y-STR guidelines. And my talk will talk about y-STRs to a large degree. And I just wanted to mention what these guidelines are going to say. And I realize that many of the participants are not in the US, but I think that it would be fair to say that SWGDAM guidelines are still of interest to other people, wherever you are. Anyway, what basically the new SWGDAM guidelines are going to recommend is basically prescribe the use of y-STRs in certain case circumstances. We're taking a proactive stance and saying that labs should pursue y-STR analysis as the most appropriate means of detecting a male contributor in some forensic samples. In some forensic samples, that's what you should be doing. In order to proceed with y-STR analysis, one needs tools, and the guidelines will state, and these guidelines aren't actually released. They've been voted upon and approved by the SWGDAM membership, and should be released in the next few weeks or month or so. But anyway, it says that quantitative PCR that enables the estimation of the quantities of both male and female DNA is an important tool for the determination of an amplification strategy that maximizes the potential for determining male components. So it's basically saying we need a tool to enable the estimate, an estimate of the quantity of male and female. So that's important. And basically, it's the ratio of total or female DNA detected in the sample relative to male can be predictive of the ability to detect a male minor contributor in a mixture. What the guidelines say is that the lab should establish guidelines, for example, based on a total to a male DNA quantities for when detection of a male minor contributor to a mixture is not expected with autosomal typing. And if, however, if the lab doesn't use a ratio of total or female to male is not used, then the lab should establish alternative criteria for establishing the strategies to maximize this potential for detecting male DNA. And lastly, samples for which detection of a male minor contributor is not expected with autosomal typing should be conserved for y-STR typing. So I think these are clear statements that y-STR typing is here to stay. In fact, and should be used under appropriate circumstances. y-STR typing does not supplant, is not intended to supplant autosomal STR typing. However, in certain circumstances, it is basically what one would expect to do. It's basically state of the art, and it's basically expected that y-STR typing would be done in certain cases. Okay, so with that preamble, I just want to briefly go through the samples and the studies we did in this that I want to talk to you about. So we're talking about extended interval post-coital samples. These basically are samples, vaginal samples that are provided greater than 24 to 36 hours or so. It could be 24 to 48 hours after the incident. And this happens often because the victim is incapacitated through drink or drugs, or there has been date rape, or it's been an assault on children, and the child doesn't quite realize what has happened. So it does happen that the victim comes later, comes several days after the event to report the incident. And the problem is, of course, that autosomal STR profiling diminishes rapidly, the success rate diminishes rapidly as that post-coital interval is extended. Beyond 72 hours, 3 days, it's not normally possible to obtain a good autosomal STR profile from the male semen donor. The problem is that in the classic literature, serology and reproductive literature, we know that sperm survive for 7 days or more in the cervix. So basically, we know that there should be sperm from the semen donor present. We just need to be able to have tools to recover that information, the genetic information from the sperm. So what my lab has done over several years is we've developed several methods. What we did was we, to summarize some of this early kind of work, we've developed Y-chromosome specific nested PCR amplification. Basically, we took the Yfiler kit and designed nested primers to improve sensitivity, so that we were able to manage to get profiles up to and including 9 days after intercourse. And this is work that we've just recently got accepted for publication. This is a significant extension of the interval by which male profiles can be recovered. Previously we'd found 5-6 days, but we're confident now that we can get results 9 days after the incident, and some of the data I will show you will support that later on in the talk. In terms of, I've often received some people expressing concern this is going to increase the workload for crime labs. However, some of the studies we've done, I'll show you one here, that the estimated number of cases with greater than 6-day samples is quite small. For example, in Orange County, Florida, only 4% of sexual assaults were reported greater than 72 hours after the incident. So it's a small number, small percentage, but they do occur. Every lab will come across them at some point. Anyway, the study itself that I referred to there with 9 days only used 4 donor couples, and what we did was we extended this to a much larger number of samples in collaboration with Pat Speck, who's a nurse, a forensic nurse at the University of Tennessee Health Science Center. We looked at a larger number of donor couples, 74 donor couples, and with these 69 reported results. And what we did was we took 4, 7, and 9-day samples after intercourse. We took cervix and fornix samples from around the cervical area, and each were collected after a separate act of intercourse. And we compared standard analysis, Yfiler, with enhanced analysis, which was Y-nested pre-amplification. To summarize some of the results, then we had 84 samples from the 28 couples, 4, 7, and 9 days. And what this graph shows is that in the blue you have on the x-axis. In the x-axis you have all the different donors, and on the y-axis is the allele recovery in terms of Yfiler. You can see there's 17 alleles on the y-axis. So you can see in the blue that with the Yfiler, standard Yfiler, you got some results, not very many, but you got some results. Whereas if you look at the yellow with the enhanced methods, we got a substantially improved ability to recover DNA profiles from these samples. This was 7 days. So that was good. That showed that enhanced DNA methods worked. However, not everyone will have access to these enhanced methods, and so with the next generation y-STR kits being released, we now have Promega and LifeTech now. There's new chemistry, and apart from additional loci, we were hoping that basically we might be able to eliminate the need for this preamplification. The increased sensitivity and robustness of these kits may help us perform the same analysis we did, but not having to use preamplification and nested PCR. So what we did was we took a set of these samples that we had used in this previous study, and I'll talk about them in slightly more detail, and we processed them using the quantitation system, the Quantifiler Trio system that was discussed earlier. This Quantifiler Trio system allows us to measure the total human quant. It enables us to, and also the quality index, degradation index, because of the ratio of large to small, or small to large, the ratio of the fragment. There's a male DNA quant part to this, and I should say that these the targets being measured are multi-copy targets, and so they're extremely sensitive, much more sensitive than say the previous Quantifiler product. There's a male DNA quant, and then you're able to measure the female to male ratio. Once you've got that information, you might be able to make a decision about autosomal STR analysis versus y-STR. Autosomal STR analysis would be if there's a low ratio, y-STR analysis perhaps if there's a high ratio, the female to male. And if we use Yfiler Plus over say Yfiler, you should get improved sensitivity perhaps, and more robust and better discrimination. So that's the concept. And so what we did was, now to talk about the study itself, can we improve our analysis of extended interval post-coital samples using this integrated modular system involving quantitation, a better quantitation system, and the more robust Yfiler Plus y-STR system? And this is not a typical validation study, and these are very, very challenging, as you'll see, very challenging and unusual sample set that most people in this world will never have to deal with. But nevertheless, it served to illustrate the potential efficacy of these new tools. So then, to just talk about the goals, well, look at Quantifiler Trio. Can we improve the quantitation sensitivity? The majority of our standard extracts are undetectable quant Y value using previous kits, undetectable quant Y value because they're very the postcoital interval is very large. Female to male ratio determination, how much female DNA are we actually dealing with? And does undetectable quant result in this new kit, does it mean no profile recovery? That's an interesting question. And with the Yfiler Plus, could we get improved profile recovery sensitivity compared to previous, say, Yfiler? That would eliminate the need for pre-amplification. And could we recover profiles with vast excess of female DNA? So in this post-coital study, we had 28 of these study couples where we had an additional sample available. We concentrated the sample, the DNA sample, and we looked at baseline 4, 7, and 9-day samples. But we mainly focused on the 4, 7, and 9-day samples for this particular part of the study. And so there was 84 samples. Now, I should say that these were non-differential extracts only, non-differentially extracted. So they're going to be genuine mixtures of male and female. And there was cervix and fornix samples as well. So just so you know what the samples were, they're not lower vaginal samples, they're upper vaginal samples. And just as a baseline, here's if we took these same samples and run them with Yfiler, you can see that, not Yfiler Plus, just Yfiler, then you can see 4-day, 7-day, 9-day. We got some results, not a lot, but some days, some results, and you should compare that with what we're going to see soon. Okay, that's just the baseline. Yfiler, we should be able to improve upon that. So let's just go through some of the data then. So what we have here is on the x-axis, and there will be a few graphs like this. On the x-axis is just the listing of the 84 samples, and on the y-axis is various parameters. And in this case, what we're looking at is this is Quantifiler Trio, and we're looking at total yield of human DNA. How much DNA did we recover, human DNA, from each of these 84 extended interval post-coital samples? And so you can see that the yield on the y-axis is nanograms, and basically we recovered anywhere from 0.5 micrograms to about 16 micrograms. Most of which, if you look on the lower left, the 2000, that's 2000 nanograms. Most of the samples yielded more than 2 micrograms of DNA, and this is not surprising. These are extracts from vaginal swabs. Non-differentially extracted, but these are the quantities we recovered, total quantity. When we looked at the average total male DNA yield, however, because we obviously with the quantifiler we can measure the DNA yield, male DNA. What we see is in the 4-day there was an average of 1 nanogram, 1.1 nanogram with a wide variation, 4-day. So in 4 days we were able to recover from the total extract approximately 1 nanogram on average. When you look at, however, 7 days and 9 days, the amount recovered is very low and gets, obviously the amount recovered after 7 and 9 days is much less than 4 days. With the in this study, the recovery was 60 picograms average, just the average, in 7-day and 150 picograms average in the 9-day. Now these are gross averages. When we looked at the, obviously with the Quantifiler Trio, it allows us to measure the female-to-male mixture ratio. So if you look at 84 samples, on the y-axis you now have the mixture ratio of female-to-male. And what you see is that, I've summarized in the top right-hand corner, is that basically the ratio of female-to-male in these samples ranged anywhere from 330 female to 1 male to 4 million female to male. So you can see these samples are extremely challenging from the standpoint of trying to get that male profile. In other words, autosomal STR would not be possible with these particular samples. Remember, they're non-differentially extracted and they're mixtures. And so with a 333 to 1, you would never detect the minor contributor, and it goes as high as 4 million to 1. And that's why I said to you earlier that these are unusual samples. Okay, what about the index, the degradation index, the quality index? Well, if you look at the 84 samples, you can see that the degradation index, there's no degradation, no significant degradation in these samples because they are all right about 1, anywhere from 1, 1.5, and that means there's no evidence of degradation. Now, at first blush, we thought that's interesting, but of course it makes sense because the vast majority of the DNA there is female DNA, and that female DNA is not degraded. Any degradation of the male in the sperm, if in fact that's the case, we are not 100% sure that is in fact the case. But if there was any degradation of the sperm, you wouldn't see it in this particular assay. So the degradation index works, but if there's a minor contributor, it may not pick up that minor contributor degradation. So we have to be aware of that. Okay, so that's a general sort of description as to what the samples look like in terms of quantity of male, degradation index, the quantity of total, etc., quantity of total DNA. Now, what about Yfiler Plus? So all samples, because this was a study to determine the efficacy, the usefulness of these systems, all samples were amplified in this study, regardless of the quant value. So we used 1 nanogram if possible, and you can see only a few had that. If not, we used the maximum volume, used if 1 nanogram is not possible. We used the standard 30 cycles for the Yfiler Plus. We used the 3130, we used POP7 as opposed to the standard POP4. That's just what we use in our lab. We did use a 16-second injection time since our lab is an enhanced DNA typing lab often, and we use that standard injection time, that is our standard injection time, 16 seconds. It was suggested by LifeTech after we'd done this to perhaps reduce it to 10 seconds. But we do our own thing, and we had used the 16 seconds. So the data here is showing 16-second injections. But one thing you see on the bottom right is the PCR protocol for the Yfiler Plus. It's only a 92-minute amp time, which is pretty fast. So what about the same samples then? Once we've typed, what we've done is taken these samples now, and we've added either 1 nanogram of DNA, male DNA, or we've added the max volume that we could get, 10 microliters. And what we find is that here's the Yfiler Plus. results. How much did we actually put into this? This just summarizes the amount of the input. As you can see, there's a very wide range of input, the maximum being 1 nanogram, but the vast majority being much less than that. When you look at, however, how much human DNA is placed into each of these PCR reactions, remember we added 1 nanogram of male DNA independent of how much female was present, or we added 10 microliters of extract independent of how much female was present. And here's what we are actually adding to the PCR reactions in this case. You can see that on the y-axis we're talking about nanograms, and so the first on the y-axis the first value is 2,000. That's 2,000 nanograms. So that's 2 micrograms. So you can see that where the red line is, that's 1 microgram. Most of the samples that we analyzed had in the PCR reaction mix more than 1 microgram of DNA. So more than 1 microgram of human DNA was present in these Yfiler amplifications. Now, what about the Yfiler Plus profiling success rates? And remember, I'm using Yfiler Plus. If I've said Yfiler, I mean Yfiler Plus in this latter part of the talk, in case I've gone back to say Yfiler Plus. The profiling success rate in detail, on the y-axis there are 27 loci, so it shows you briefly when you look across the graph how many samples gave 27, how many gave 24, down to 0. You can see quite a few of them gave full profiles. A lot gave nothing, and some gave intermediate value as well. Summarizing that here in the next slide with pie charts showing 4-day, 7-day, 9-day, showing number of alleles recovered. Basically, with a 4-day, 39% of the samples gave a profile, a Yfiler Plus profile with greater than or equal to 21 alleles. When you go to 7 days, 18% gave profiles, Yfiler Plus profiles with greater than 21, greater than or equal to 21 alleles. And 9-day, 22%. 1 in 5 profiles gave greater than or equal to 21 alleles using Yfiler Plus. And you can see for yourself that there was quite a high degree of success, startling degree of success, I would say, with obtaining the Yfiler Plus profile from these all of these classes, 4, 7, and 9 days. Let's look at a couple of examples of the profiles, the Yfiler Plus profiles. Here I've taken just two samples, one positive, one negative. Look at the 4-day on the left-hand side. The 4-day profile on the left-hand side, that's a Yfiler Plus profile, and you see that 27 out of 27 alleles were recovered. And what in fact, that makes sense to us because the Y-Quant showed that we had 0.0538 nanograms per microliter. We added 538 picograms into an amp, so half a nanogram into the amp. So I would expect to get a result perhaps. The bottom says that we added 2.7 micrograms of total DNA into that amp, and the male-female ratio was 5,000 to 1. However, because we added half a nanogram of male, we got a result. So that makes sense. Now look at a 9-day, one of the 9-day samples, where we get no results, 0 out of 27 alleles. The Y-Quant value there was 0.0001 nanograms per microliter. When we added 10 microliters of that, we had 1 picograms into the amp, 1 picogram. So we don't expect to get a result. We get no result. And we added at the bottom, it says 1.7 micrograms of total DNA. That's the last quantity of DNA, and the male-female ratio was 1.7 million to 1. So we didn't have a hope of getting a result there. But we normally wouldn't proceed with that sort of information. But in this case, we did this. We typed all of them to see what the results would be and how it correlates with what the prediction would be. the Quant and Quant results. So if you look at more detail here, some graphs showing summary data of all of these samples, all of the Yfiler Plus results. So we look here, the number of alleles versus the total male DNA in the AMP. So if you look on the x-axis, total male DNA in the AMP in picograms, it goes from 0 to 200 picograms, and on the y-axis, the number of alleles recovered up to a maximum of 27. You can see there's an increase from 0 input. You can see that as you increase the amount of male DNA going in, you get an increase in the number of alleles detected. And so more or less with 100 picograms of male DNA in these challenging samples, remember, they all have very, very large quantities of female, that we get results more or less complete profiles 100 picograms or more. And I have cut off the other results at the end. This is the low range, because at the higher input DNA, we always got a result. Okay. If you looked at the number of alleles recovered versus the female to male ratio, did it have any effect? Well, on the x-axis this time you have the female to male ratio, and the first, as you go along the x-axis from 0, the first point you get is 200,000 to 1, and what you see is that as you increase the female to male ratio, you get fewer alleles, and there is some evidence that the high female to male ratio does adversely impact recoverability of y-STRs at these extremely large female to male ratios. So up to 100,000 to 1.1 million, you can sometimes get informative profiles. That's at the lower end of that is at the x-axis before that first 200,000. It'd be 100,000. If you look at 100,000, you get some reasonably probative profiles. But you can see, I've indicated on the graph that you can see, for example, one sample is 8 picograms that gave 5 alleles, whereas one other sample that had 8 picograms with a much higher female to male ratio, we get no results. So perhaps at these extremely high levels of female to male, there is some diminution in our ability to recover profiles. But these are extremely large female to male ratios, ones that you would not normally encounter with standard forensic type samples, whatever that means. Now, what about the number of alleles versus total human DNA? Well, of course, total human DNA will comprise mostly in these samples, mostly female, of course, because we know that the quantity of male is a nanogram or so, and we're dealing with microgram quantities of DNA, so the rest is female. So you can see there's no correlation between the y-STR alleles and human DNA. Nevertheless, if you look at the 10 micrograms of total human DNA, you still get some very highly informative profiles. Okay, so now what about the question of, we use the Quant system. What about the ability of that Quant system to tell you, predict whether or not you will get a y-STR profile downstream? And so when we looked at all of the results from the 84 samples, we looked at the following. We saw that there were a small number of samples that said undetectable, but yet we found some alleles recovered. Now, they're listed here, and most of them had 3 alleles, 2 alleles. If you go down this column, there are 1, 2, 3, 4, 5, 6 kits on the left-hand side. 4 of them had 3 alleles or less, with low RFU values for the most part. The other two samples where we initially got alleles, there are technical issues there that very poor quality electropherograms, and they're basically pull-ups and things of that nature that we are rejecting. They are not true alleles right now. So basically, these undetectable if you were to run them, you're going to get not profiles that you would really, I myself would never report these particular profiles, the ones we've seen here. Now, on the other hand, so let me go back to that. Sorry, these could be false negatives then. You know, in other words, the quant system says there's not going to be a profile, but you get a profile. Is that a false negative? Well, I would say no, based on what we've, because the profiles are such poor quality. There's only one or two alleles with very low RFUs, and they're not good profiles. What about the other side of the coin, where there were samples? Were there any samples with a detectable quant but had no profile? There were several of these where there were no alleles whatsoever detected, but there was a quant. But when you look at the quant values, which you see in the red box, every sample was less than 0.002, and that 0.002 is significant because that's one of the standards in the Quantifiler Trio kit. And so, would these be false positives? Would these indicate that? Would these be false positives? Well, let's look. The lowest, if you look at the Quantifiler Trio, the lowest standard in the standard curve is 0.002 nanograms. What this graph is showing is the standard curve, and there are 5 standards, basically from 2 nanograms, 0.2, etc., tenfold dilution, down to 0.002 nanograms per microliter, which is 2 picograms per microliter. So are quants below this level relevant or accurate even? So basically, if you go below 0.002, there's possibly no profile recovery, because that's what we saw with the previous slide. When we looked at the samples again in more detail and say, okay, let's look at samples with less than 0.002 nanograms with a potential profile. The other one showed less than 0.002 with no profile. This one, is there a profile? And again, we looked at these, and again, they're very, very low signals, not very small number of alleles, mostly with less than or equal to 7, less than or equal to 125 average RFUs, and so therefore these profiles are poor quality profiles again. So I think our conclusions are the following: that what I've shown in this graph is the typical situation where you look at true positives and true negatives. So what you have is two bell curves showing the true positives, and one showing a true positive TP and one showing true negatives. What I mean by true positives here is would be a situation where there are profiles, there are male profiles, you want to get them. The true negative means there's no profile there, you're not going to get anything, doesn't matter how hard you try. And what happens in any analytical system is that you have a decision threshold. It's mentioned here, the uncertainty range. And you can see that because there's overlap between the true positive and true negative, you get incidents of false positive and false negative. And what happened with the previous kit is that the diagnostic cutoff point, say given in the dotted line, I'm making this up, let's say the dotted line, what that meant was that you may have made a decision, you may have thought that there was an undetectable quantity of, there's an undetectable quantity of male DNA, therefore you would not get a profile. But of course, that decision threshold, because it was a more insensitive system, did not allow you, there were false negatives. This system here that we have, the Quantifiler Trio, the quant threshold is much, much lower, much less, to such a degree that you can go low right down to the place where it's mentioned there, where you will not get any false negatives. Now, I recommend that labs wishing to use this system evaluate the system and decide what the threshold would be for themselves. 0.002 seems reasonable, or slightly less, but you can use the undetectable quantity as well. I would advise the labs to basically evaluate in their own hands, because they may be using a slightly different amp cycles, they have different conditions, but I firmly believe that this system allows one to have a quant threshold that you can use to make decisions. Okay, so I want to just finish by saying these were very difficult specimens. I want to then quickly talk about a study we did with not so difficult specimens perhaps that may represent more closely with what happens in normal crime labs. This time we took cervical vaginal samples 1, 2, and 3 days after intercourse. These are good samples now, meaning there were separate acts from one donor couple. We took precoital swabs, and the donors were staying for 7 days between collections. We used a differential extraction. We happened to use 3 washes of sperm. May need to increase that based upon our results. We used a sample elution volume of 50. We used the Quantifiler Trio, where we took 4% of the extract, 2 microliters, and we amplified these samples with autosomal STRs using GlobalFiler. We used the y-STR's Yfiler Plus, and we amplified all fractions with both kits regardless of the quant, just to see if our predictions, because we're going to predict what the outcome would be and what our actual outcome was. So here's the precoital results, and basically in this table you have on the far left 1 day, 2 day, 3 day, and these are precoital samples. So these are the ones that are taken prior to intercourse, prior to the samples being taken to try and show that any DNA we find comes from the act itself and not from any remnants of previous acts of intercourse. And then you have the fractions, NSPs, non-sperm fraction, and the sperm fraction. And then you have, going along the various columns, you have the large autosomal and the small autosomal. That allows us to measure the total human quant. We then have TY, which is the male quant, and then the total male quant, meaning what I mean by the total human and total male is how much we actually recovered in these samples. What's the total recovery from that specimen? And then we have the male to female ratio and the degradation index. So what you find is that basically, if you look at the 1 day non-sperm fraction, we got 18 micrograms of total human DNA, and we got no male DNA from that. That's the top. If you look at the top line there, non-sperm fraction, and the degradation index, there was no degradation. So in the sperm fraction of the day 1, we did find we had 9 nanograms of DNA, and that was in the sperm fraction. So there's the sperm fraction, the differential there is not 100% perfect. One can use this system, in fact, as an aside, to optimize a differential extraction procedure. If you look at day 2, similarly, we non-sperm fraction, there's 20 micrograms of human DNA. The non-sperm fraction, nothing in the sperm. And when we go to 3 day, we had 2.8 micrograms of non-sperm human DNA, 0 in the sperm fraction. So female DNA was present in all samples and fractions. When we typed this using GlobalFiler, we found only the female profile in the non-sperm fractions. In Yfiler Plus, we did test Yfiler Plus. We found no male profiles in any of the samples. That's the pre-samples. So if we come to the post-coital samples themselves, I should say that we used we typed them with both GlobalFiler and Yfiler Plus, as I said. GlobalFiler, we added 1 nanogram if possible, 10 microliters for samples with lower undetectable quantity, 29 cycles standard, and with Yfiler. And the GlobalFiler wasn't introduced earlier. GlobalFiler, has 21 loci, STR loci, autosomal STR loci plus a melogenin, but it also has a Y insertion deletion and a y-STR DYS391 in male samples. Yfiler Plus, we added 1 nanogram if possible, 10 microliters for samples with low or undetectable quantity, 30 cycle standard, and 10-second injection time. Okay, and here's the results of this this experiment. And if you just concentrate on the top table first, because the bottom table is the same except for the results in the right-hand side. This table shows 1 day, 2 day, and 3 day. This time, non-sperm and sperm again, showing again the actual quantities of the results for the human, total human, the total male-female ratio, degradation index, etc. So we concentrate first of all on day 1, non-sperm fraction. The non-sperm fraction had a large quantity of human DNA, 14.6 micrograms. There was 26 nanograms of male DNA in the non-sperm fraction, which indicates, of course, some carryover, as you sometimes get in it's not perfect differential sometimes. And the male to female ratio was 569 to 1. There was no degradation there. So with that, what would you expect to find in GlobalFiler? We would expect to find in the GlobalFiler, since the ratio of male to female is 500 to 1, we would only find the female profile due to the higher male-female ratio. And what about the Yfiler Plus? Yes, well, there's 26 nanograms in our, we have a total of 26 nanograms. We should be able to find 1 nanogram to be able to type. And so we expect the male profile. If you go down to the second table, the actual observed results are present. So yes, lo and behold, we got a female profile in that 1 day, non-sperm, and we found a male profile in the Yfiler Plus, so that's good. If you then go back up to the top table, the sperm fraction of the 1 day, the sperm fraction had 113 nanograms of human DNA, and there was plenty of male DNA, 106 nanograms of male DNA, and the male to female ratio was 1 to 0.06. In other words, there was 17-fold excess of male this time. There's more male than female, 17 to 1, which is what you'd expect from a differential. And so what would we expect to find there? A GlobalFiler, we would expect only to find the male profile expected. Would we? Maybe a minor female. And Yfiler Plus, we would fully expect to find the male profile. And what did we find? Yes, if you go down to the second table, you see a mixture. Female is a very minor component. And with GlobalFiler and with Yfiler Plus, we found a male profile. If you then go to the 2 days, we do the same thing. You look at the various parameters, and we would predict basically from the GlobalFiler that in the non-sperm fraction, we would expect only a female profile due to the high male to female ratio. And with the Yfiler, there was a low quant, low quantity of male, and maybe a partial profile. When we go to the actual what the results showed, in fact, with GlobalFiler, we only got the female profile, and with Yfiler, we got no profile. That's in the non-sperm fraction. When you go to the sperm fraction of the day 2, the expected results based on the results were that the quant results was that we perhaps expect a mixed profile with the GlobalFiler because the ratio is approximately 1 to 1. Close to 1 to 1 of male to female. So we expect a mixture. And we expect to find a male profile since we had 12 nanograms of total male. And what do we find? Yes, in the GlobalFiler, a mixture, a 1 to 1 mixture of male to female. And Yfiler Plus, what do we get? Yes, a male profile. When we come to the 3 day, what do we find there? We found with the 3 day that with the non-sperm, we expected the female profile in GlobalFiler and no profile in the male. And what do we find? We find exactly that, a female profile in day 3, non-sperm, GlobalFiler, female only, nothing in the Yfiler for the non-sperm fraction. Also in the male fraction, or the sperm fraction, we didn't expect a profile either from GlobalFiler or Yfiler Plus based upon the results. And what do we find? Nothing. So the observed results were consistent with expected results based upon the Quantifiler Trio results. So I think because time is moving on, I'm going to bypass these profiles which I actually had generated that showed some of these profiles. And so I'm just going to pass on and say that the conclusions were that With the quantitation system, there's excellent correlation between the male quant and profile recovery. The negative quant threshold-based negative quant means a negative usually means an unusable or negative Yfiler Plus profile. And the observed autosomal and Y results are consistent with the expected based upon the quant and the female-to-male ratio. The quality index can tell us something about our samples, in this case, no degradation, but of limited use in our particular instance here, but useful in other cases, I would say. In Yfiler Plus, it was excellent discrimination, very sensitive chemistry. If greater than 100 picograms of male, we mostly got full profiles. We obtained results from high quantities of background female and many usable profiles, even with female-to-male ratios ranging from 333 to 1 to 100,000 to 1. So with that, I should like to acknowledge Erin Hansen, who's actually done all of the actual work here, the actual bench work. She's a research assistant professor in my lab. The group from the Human Identification Group, Robert Green, Allison Holt, Christina Borman-Chung, Julio Molero, and Melissa Kotkin. Pat Speck and the University of Tennessee Health Science Center team. Part of this was sponsored by NIJ, some of these samples. And my own research group, Haley O'Brien and Kelsey Neary, 2 undergraduates in the lab. And with that, the end crowns all, and that old common arbitrator time will one day end it. And thank you for your attention. So I don't know if there's room for questions. Sorry about taking a minute longer than I should have done.
No worries. We'll actually have time for just a couple questions here, and then any other questions will be answered offline as the presenters will have your information. So our first question is, when will the Quantifiler Trio and HP kits be available?
Okay, so this is Allison Holt. The kits are now available on restricted release, so you can contact your sales rep to order the kits.
All right. And one question for you, Jack. How were these samples extracted, and what was the final volume of extract prior to Quant?
We basically combined extracts from the cervix and fornix, because these were remaining samples. And we concentrated them down to 15 microliters using post-PCR purification, not post-PCR purification, using spin columns. So we concentrated the extract to 15 microliters and used 10 microliters of that for the amp, or 1 nanogram, whatever we needed. It's because we took two of that 15 for the Quantifiler Trio.
Okay, thank you.
Yeah.
And thank you, everyone, for attending today's webinar, and thank you to our great speakers, Allison Holt and Jack Ballantyne, and our sponsor, Life Technologies.